Hey everyone, it's Jamie Batts, your instructor for A&P2. We're continuing on with our discussion of the lymphatic system. In the last lecture, we were talking about the lymphatic vessels and the overall structure of lymph. Now we're going to get into more details about the lymphocytes and the cells of the lymph themselves. Let's go to, I think it's this one. There we go. That's where we left off. And click, click. All right, so let's talk about the lymphocytes in general. This is 20 to 40% of all of the white blood cells in our body. So less than half are these lymphocytes. Don't get the term leukocytes confused with lymphocytes, right? They both begin with an L, they both end with cyte, right? Leukocytes are white blood cells. Lymphocytes are special white blood cells that are for our immune system and part of our lymphatics. So most of the lymphocytes are out in the lymphatic tissues that we were just going over, and there's three classes of them that circulate in our blood. So you have T cells. You've probably heard of these before. T cells. This is the majority of the lymphocytes that are floating around. These are responsible for what we call cell-mediated immunity. This is that cell-to-cell combat. Oh, I see you. You're a foreign invader. I'm going to gobble you up and destroy you, right? B cells are a much smaller percentage. These are antibody-mediated immunity. So this is, oh my gosh, I recognize you. I need to go tell my friends. We need to make antibodies so we can fight you off, right? And then there's NK cells, or the coolest cell ever, natural killer cells. That's what they're called, literally, natural killer cells. And what they do, well, this is a small percent, 5 to 10% of our circulating lymph. What these things do is basically surveillance. They're out, they're patrolling, they're checking cells, they're making sure no cells are growing out of control, right? No tumors are starting. They're making sure no cells are infected by a virus. And if they are, then there's a certain cascade of response that they will do, which we'll get into eventually. So all classes of lymphocytes are sensitive to what we call specific chemicals or antigens, right? So they are going to respond in a very specific way based on a specific antigen. Most of the antigens that come into our body are pathogens. These are parts or products or pathogens, foreign compounds, etc. So these are things that are not recognized by our immune system as self, right? It's not a Jamie cell, it's some other random cell that doesn't belong here, right? Most antigens are proteins that are on the surface of the cell, like lipids or polysaccharides, and the antigens stimulate that immune response. This should sound familiar to you, right? We talked about this briefly when we talked about blood types, right? A, B, O blood system and the D antigen. Those antigens were going to induce an immune response called agglutination, or that clumping. You see the same thing here in the lymphatic system. Let's talk specifically about T cells. There are three major categories of T cells. Cytotoxic T cells. These are the really bad ASS guys, right? They're really bad, right? They're I mean, bad in a good way. They're awesome, right? These are the guys that are actually out there attacking the foreign cells, fighting the viruses, right? They're commonly involved in like direct contact with other cells, right? So they're not attacking by like sending a chemical out there, right? These guys are actually out there like fighting. So cell-to-cell combat, right? These are the primary cells that are involved in what we call a cellular immunity or cell-mediated immunity. So this is one cell recognizing another cell as a foreign body, as an antigen, and attacking that specific cell right then and there. Then there are helper T cells. Helper T cells are going to stimulate more T cells and B cells. So these are also sometimes known as regulatory T cells. They work with suppressor T cells to control the sensitivity to a particular antigen. Suppressor T cells are there to inhibit the activation of T cells, kind of turning them off. And you might say, well, why would you want that to happen? Well, in some cases, your body needs to adjust to a particular antigen, right? Maybe you just got an organ transplant, right? And there's antigens that your body needs to suppress so that your body can accept this new organ or tissue into it. Or maybe it's a food allergy situation, right? There's lots of different situations where you would want to suppress the activation of B and T cells. Let's talk about B cells quickly. B cells, when they're stimulated, they will undergo mitosis and form something called a plasma cell. A plasma cell is a very large cell, and what that cell does is produce antibodies. You've heard of antibodies before, right? Antibodies antibodies will attack antigens. So these are responsible for an antibody-mediated immunity. Our T cells are responsible for cell-to-cell combat. Our B cells, instead of the B cells themselves going up to a foreign antigen, gobbling it up, punching it in the face, right, destroying it, what the B cells do is they say, whoa, we recognize you as a foreign antigen. We're going to come back here. Excuse me for a minute. I'm going to turn into a plasma cell, and I need to make some antibodies, and my antibodies are going to do the dirty work for me, right? So antibodies will circulate in the body fluids and attack any of the antigen targets throughout the body. So it's just a different strategy, right? It's all about, you know, making sure that there's different backup plans to defeat any type of attacker in the body. And that's where natural killer cells come into play. Natural killer cells, or NK cells, will attack foreign cells, your own body cells, cancer cells, or virus cells that have been infected or mutated in some way. So this is continuous monitoring of all of the body tissues, checking them, making sure they're good to go, making sure they're squared away, making sure that they're not, you know, mutated or infected by a virus. So here you see the different classes: T cells, B cells, natural killer cells. T cells come in 3 varieties. There's a few more varieties, but your book leaves them out. Cytotoxic T cells, helper T cells, suppressor T cells, and then our B cells, which will differentiate into plasma cells to make antibodies. So the whole process of creating lymphocytes is called lymphopoiesis. Remember, we had erythropoiesis, right? So now we're looking at lymphopoiesis. In lymphopoiesis, because we're talking about lymph cells, these cells are originate in the bone marrow, right? And then they're going to be transported out into the lymphatic system, primarily to the thymus. The thymus is the site of major lymphocyte maturation. Then they go out into the peripheral lymphoid tissues where they can sit and wait and kind of, you know, twiddle their thumbs, so to speak, until they need to be activated. The red bone marrow is the primary catalyst in creating lymphocytes. The hematopoietic stem cells produce lymphoid stem cells, and the lymphoid stem cells will then differentiate as needed. So those lymphoid stem cells can produce 2 main types of cells. One group is going to go to the thymus and develop into T cells. That's literally what the T in T cell stands for. It's like thymus dependent something. That's what the T stands for. The second group is actually going to stay in the red bone marrow. They're going to divide and produce either B cells or natural killer cells. So the development of the cells in the thymus is kind of tricky because the thymus is actually separated from the blood. So these cells, which are originating in the red bone marrow, travel in the blood to the thymus, and the thymus is going to allow in only these special lymphatic stem cells, because there's a blood-thymus barrier, so there's not actual contact between the blood and the thymus except for this small exchange of stem cells. So these cells are going to divide in response to thymic hormone. So once these stem cells get to the thymus, they're just going to wait around until the thymus releases these little hormones that we'll talk about in a minute, and then they undergo some type of selection process where they're going to ensure that they won't react to normal body cells. Up to 98% of the T cells don't make the cut. So your body's making T cells much more rapidly than it is releasing them into the blood. And then mature T cells will re-enter the bloodstream, go to the peripheral lymphoid organs and tissues, and wait until they are needed. So here you see, where's my notebook, my notebook of knowledge. Set it aside over here. Just want to make sure I hit everything that I wanted to talk about. Yes. So here we have just a graphic organizer showing you the relationship between the thymus and the red bone marrow. Everything originates in the red bone marrow, producing lymphoid stem cells that go to the thymus, and lymphoid stem cells that will differentiate into B cells and natural killer cells. Natural killer cells are responsible for immunological surveillance. B cells are for antibody mediated immunity, and the T cells will develop in the thymus. The thymic hormones drive the development of those T cells, and we'll look at that in a minute. So the T cells and B cells migrate from their sites of origin. They retain their ability to divide. So once they're in place, right? Once they're in the peripheral tissues, once they're in, sitting and waiting in a lymph node, or sitting and waiting in the spleen, or wherever they're waiting, they're going to wait to be activated. And when they're activated, they will divide. That's one of the first things they'll do. So they have the ability to increase their number outside of the lymphatic tissue. So once the T cell develops in the thymus, it can enter the bloodstream, go to where it needs to go in the body, and sit and wait until it's called to action. And when it does, it will divide and produce more of the same cell. So you can pause the video here, go back and review this section. You know what? No, I'm going to make a different video because then we get into lymphoid tissues. So I will stop. I want to draw something for you. Sorry. We'll stop share. And still don't have anything to erase this with. Just going to use my handy dandy hand here. And I want to draw out a graphic organizer of all of these lymphatic, all of these lymphocytes for you, so that we can understand what they are, how they are, where they come from, what they do, right? So we have a graphic organizer here of lymphocytes. Hopefully this marker works. Very, very high tech, as always. So here's lymphocytes. Let's talk about T cells first. We'll draw them down here. So T cells are induced by thymic hormones. Thymic hormones drive the development of T cells. T cells can, which the T stands for thymus dependent. That's literally what the T stands for. We have regulatory T cells. Regulatory T cells control the sensitivity. To the immune response. We have suppressor T cells, TS, little s, that's suppressor. These are going to inhibit T cells and B cells. I'm just going to write inhibit T and B. We don't have a whole lot of room here. There are memory T cells. Memory T cells, which provide immunity. I'm just going to write that in quotes there. They provide immunity. Right? I'm immune to that because you have memory T cells or memory B cells, which we'll talk about those in a minute. You also have T helper cells. These are going to stimulate T and B cells. And then you also have TC cells. These are the cytotoxic. Those are the badass cells. Cytotoxic cells. These are there to actually attack foreign antigens. So you also have B cells. These are stimulated to grow by interleukins, which are just little interleukin 7 is technically what it is. You don't need to know that. But those are just little cell-to-cell messengers, so that, remember, T cells and B cells rather are going to develop in the bone marrow. It's kind of what the B stands for. So B cells are bone marrow derived. Right, sorry, my handwriting is terrible. These B cells differentiate into plasma cells, and the plasma cells will make the antibodies. And finally, we have natural killer cells, or NK cells. These guys are just basically attacking virus-infected cells and cancer cells. Any body cell that isn't behaving like it's supposed to is going to be detected by a natural killer cell, and the natural killer cell will destroy it. So, just a quick flow chart. You have the hemocytoblasts, right? Those are the stem cells in the bone marrow. These can differentiate into the lymphoid stem cells. This is all in the bone marrow. And some of those lymphoid stem cells go to the thymus, and some of them stay in the bone marrow. I'm just going to write stay in BM because I'm running out of room. Bone marrow, stay in BM. And when they stay in the bone marrow, they can mature into natural killer cells or B cells, and these cells are going to become our T cells. Oh yeah. Awesome. So now we'll stop this video and we can continue on with the next segment in the next little video.